Hi all, let's see the continuation of asynchronous data transfer. So in today's lecture, we are going to discuss about asynchronous serial transmission and the methods of asynchronous serial transmission. So when you consider two parties or two communicating parties, the transfer of the data between the two units, it can be either a serial transmission or a parallel transmission. So in parallel transmission, n bits in a message, it has to be transmitted through n separate conductor paths. In case of a serial transmission, each bit in the message is sent in a sequence, one after another, bit by bit. So that is so if you see the difference, this is a serial communication where if you consider an 8-bit information, it has to be done only, the communication has to be done only in a serial manner, bit by bit. Whereas in a parallel communication, the 8-bit message can be transferred between the sender and the receiver through 8 parallel lines at the same point of time. So this is the difference between a parallel communication and a serial communication. So in parallel communication, it is very faster, but it requires more number of wiring to be established between the sender and the receiver, and it is used mainly for short distances where speed is important. Serial transmission, on the other hand, it is very slow, but it is very less expensive mechanism. In a synchronous serial transfer, each bit of a message is sent a sequence at a time, and a binary information is transmitted only when it is available. So when there is no information to be transmitted, the line will remain idle. So a serial asynchronous data transmission technique is mainly implemented in interactive terminals which employ special bits which are inserted at both ends of a character code. In case of a serial transmission, the information is transmitted one bit at a time. So whenever your information has to be transferred, for example, between your CPU and the keyboard, so say information has to be transmitted from the keyboard to your CPU or to your memory. So the keyboard can take only an ASCII value. ASCII value is nothing but a 8-bit character or a 1 byte character. So 8 bits at a time, one after another, will be transmitted using a serial asynchronous data transmission technique, in which you are going to employ some special bits apart from the character bits, which are 8 bits, which are inserted at both ends of your character code. So with this technique, each character consists of three parts. One is a starting bit, character bits, and stop bits. So if you want to transfer one character at a in case of asynchronous serial transmission mechanism, you have to insert a start bit at the starting of your character and a stop bit at the end of your character. So the start bit in the case it is always 0, and it is used to indicate the beginning of your character. And the character bits are nothing but your, for each and every ASCII value, you have an 8-bit representation. So bit in between the start bits and stop bits are known as your character bits. And the character bits always follow the start bit. And finally, after the character bit, the last bit is your stop bit. It is always, it can be a 1 or 1 1. It can be 1 1 or 2 ones. And that indicates the end of your character. So if you see an asynchronous serial transmission, so say you're transferring 8-bit ASCII value from the keyboard to your memory or to your CPU. So this 11000101 is nothing but your 8-bit ASCII value, and you're going to add a start bit 0 at the starting of your character, and here 1. This is an stop bit will be your 1. So here I am giving only 1 as my stop bit. You can also have 1 1 also as a stop bits. So this is how the transmission take place. So 0 means the lower pulse, 1 means the up pulse, upside. So this is how your timing diagram looks. This is an example where between the sender and the receiver, there is a flow of data, the ASCII characters. So this is considered as one character. So it has 8-bit representation. This is actual ASCII character which is sent, along with its start bit is 0 and its stop bit is 1. So like that, each and every character will be sent from the sender to the receiver in this way using an asynchronous serial transfer mechanism. Okay? So a character can be detected by the receiver. How do the character be identified? Based on certain rules. There are certain rules for transmission. Whenever a character is not being sent, the line will be kept in an idle state or a one state. So the intimation of a character transmission is detected from the start bit. Whenever we start transferring a character, it starts with the start bit 0, which is always 0. And the character bit always follows the start bit. So your ASCII value is 8-bit value. So 8 bits represents your character. After the last bit of the character is transmitted, a stop bit is detected. The line returns to the one state. So whenever after 8 bits, whenever it reaches the 1 or 1 1, that indicates that that is a stop bit. So that is how a receiver detects the particular character. So this serial transmission, asynchronous serial transmission can be done in two ways, using asynchronous communication interface or using a first in first out buffer. So what is an asynchronous communication interface? So here in case of an asynchronous communication interface, we have a bidirectional data bus. So whenever a CPU wants to transmit whenever communication has to take place between the CPU and the input output peripherals, through the internal bus by means of a bidirectional data bus, the communication takes place between them. So here, this is a transmit. The CPU will have a transmitter register, shift register, which is used to transmit the data. Along with that, each and every independent unit also has its. So the transmitter has its transmitter clock. So since both the units are, this is asynchronous transmission, each one have their own clock. This is the transmitter clock, and it also have its own control register. Similarly, at the receiver side, the receiver will have its receiver register, shift register, and receiver control clock and status register. So this is a timing and control unit which contains of chip selection, register select, IO read, and IO write operations. So whenever your chip selection inputs are is 1, and whenever your RS register select is 0, it performs a write operation on the transmitter register. And similarly, whenever your chip selection input is 1 and the register select is 1, it performs a write operation into the control register. Similarly, whenever your chip selection input is 1 and your register select is 0, it receives the data, receive register. It reads the data. So the receive register will receive the data. And similarly, when chip selection is 1 and RS is 1, the status register and data bus. So here, whenever a CPU, say for example, the transmitter is your CPU and the receiver is a monitor. So whatever data that is transmitted by the CPU, it has to be displayed onto the monitor. In that case, the transmitter register will accept, the CPU will place the data on the bidirectional data bus, the internal bus, so that it will be first transmitted into its own transmitter register. So the transmitter register accepts the data byte from the CPU through the data bus, and it is transferred to the shift register for a serial transmission. At the receiver side, what the receiver consider here, the receiver is monitor. So the receiver will receive this particular information and copy into its own shift register, and until complete data byte is sent to the receiver register. Once it receives all the data, it will be sent to the receiver register. From the receiver register, it is sent to the corresponding peripheral device or a monitor as an output. So the control register bit, what is the baud rate, what are the number of bits in each character that is being transmitted, whether to generate the check parity, what are the number of stop bits, it is 1 1 or 2 ones. All the information about the information which is being transmitted is stored in the control register. And the status register gives the status information about the receiver. If CPU wants to transmit information to the monitor, it will first look into the status register, whether that is free or not. That gives the status information about that particular peripheral device. If it is free, then it places the data onto the data bus, which is transmitted into the transmitter register, then to the shift register. From there, it will be transmitted to the shift register of the receiver and then into the receiver register before giving it as an output to your monitor. So this is how asynchronous communication interface works. So it works as both a receiver and a transmitter. Its operation is initialized by the CPU by sending a byte to the control register. So the transmitter register accepts a data byte from the CPU through the data bus and transfer to the shift register for serial transmission. At the receiver side, the receiver portion receives the information into another shift register, and when the complete data byte is received, it will be transmitted into the receiver register. So the CPU can select the receiver register to read the byte through the data bus. So the other type of asynchronous serial transmission mechanism is a first in first out buffer mechanism. So a first in first out buffer, it is something like a memory unit that stores the information in a first in first out manner. So whichever information that enters into the memory unit, that will come out of it. So if it comes with a separate input output terminals, and the best feature of this buffer mechanism is that it can input the data and output the data at different rates. So say for example, if you consider between the CPU and the monitor. So the speed of your CPU is greater than the speed of your peripheral device. So the rate at which the CPU gives the input is very fast compared to the rate at which the peripheral device take it as an output. So when placed between the two units, this particular FIFO can accept the data from the source unit at one rate, and the rate of transfer and deliver to the destination unit can be done at another rate. So if your source is faster than the destination, consider the CPU is the source and your peripheral device is your destination. Then in those type of situations, the FIFO is useful for source data arrive in bursts that fill out the buffer. Similarly, FIFO is useful in some applications when data is transferred asynchronously. So this is how the data can be transmitted between the source and destination in a asynchronous serial manner using a first in first out buffer mechanism. So this is about asynchronous serial transfer and different methods of asynchronous serial transfer mechanism. Thank you.